another similar example, we have a fraction inside of a radical. And with these problems, I think first try to simplify the fraction. 80xy squared over 2x to the third. To simplify this fraction, now this is definitely still in a radical, so I haven't done anything to take it out of a radical. I'm just focusing on the fraction. I guess I just don't like that it's out of there, so it's still in a radical. Now to simplify this fraction, we are looking at the coefficients. We have an 80 over 2. That's a 40. Then the variables. 1x in the numerator with 3 x's next to the third in the denominator. A couple ways to look at that. I want to see that with 1x in the numerator and 3 x's in the denominator, I'll have some of the x's cancel, but with 1 on top and 3 on the bottom, after canceling, I'll have 2 left over, and those 2 x's will be in the denominator. So it's very important to be cautious about what belongs in the numerator and what belongs in the denominator. And that x squared would only go up with the 40 if our x to the third was up on top and our single x was in the denominator. So the fact that I've got a greater exponent in the denominator means that the leftover x's will belong in the denominator. So the x is taken care of. Y squared with no y's in the denominator to cancel. So we're just bringing down this y squared. So we simplified the fraction, and now it's time to simplify this radical. It's still all inside of a radical because I have not done anything about locating pairs or perfect squares. We'll come down to this next line. 40y squared over x squared. And now I'll break this radicand, numerator and denominator, up into all the prime factors. Okay, 40. I might like to do a tree on that one. It's not a perfect square. We will find 3 2's and 1 5. And a pair of y's. Pair of x's in the denominator. Okay. When the factor is in a pair in the radical is when we can bring it outside of the radical. Bring just one of them out of the radical. And we're going to be cautious about keeping numerator and denominator distinct. So a pair of 2's, we can bring out 1 2 in the numerator. Another 2 that we cannot pair up, a 5 that has no pair. There's a pair of y's. 1 y out of the numerator. Okay, here's the denominator. Pair of x's, we can bring out 1x. Now we did have some leftovers, and remember what happens when we have factors that are left over in the radical that we cannot pair up. They remain in the radical. The last thing we want to do with these problems, and it sounds like I'm just adding more to these problems, but it is based upon two main ideas, that our fraction is simplified and that the radical is simplified. But it is possible at the end of the problem that there is more simplifying to do. So really what you should think about is simplify first the fraction, then can we simplify the radical, and before you say that this problem is finished, you're going to take one last check at the fraction again. So before I say this problem is finished, I'm looking at the 2y in the numerator with the x in the denominator and just making sure that there's no simplifying that I could do there. And there are some problems where we could possibly have that happen. After we simplify the radical and bring out some of these paired up factors, we might have brought out some that match. That is possible. So just take one last check that our fraction is simplified, and it is. There's our simplified answer for this example. Okay, another example using the same ideas. First, can I simplify this fraction, 9 over 2? And we cannot. So moving on, can I simplify the radical? We have a perfect square in the numerator. The 9 is 3 times 3. We have just 1, 2 in the denominator. So think about what our steps are. We look for pairs. If I can see a pair of factors in the radical, like that pair of 3's, it means I can bring 1 3 outside of the radical. Since that pair of 3's was in the numerator, my 3 stays in the numerator. Now this 2 we could not pair up. Since we could not pair it up, it must stay in a radical. So even though the 3's in the numerator came completely out of the radical, that 2 has to stay inside of the radical. And that's where this problem pauses. It really is not over. What we want to notice is that there is a radical in the denominator. And the examples that we've looked at so far, we have not had any final answer that was simplified where there was a radical in the denominator. So this is leading us to our very next idea, which is rationalizing the denominator. So understand that this problem is not finished. What it calls for is for us to rationalize the denominator. And we know that it's not finished because we see a radical in the denominator. So rationalizing the denominator, that's what's next.